So, we talked in the last lesson about how ionic bonds are formed when you have a positively charged ion, which is most often a metal, and a negatively charged ion, which is a nonmetal. They come together, form a bond, and you get then what is called an ionic compound. It's a metal and a nonmetal bonded together by an ionic bond. Um, And what we're going to talk about in this lesson, which is lesson 4.4, is we're going to talk about how to name these compounds. So, one other thing we want to mention about ionic compounds is that they are neutrally charged. So, unlike the covalent compound, which can be polar or nonpolar, um, ionic compounds have to have a neutral charge, which means that the charges of the positive ions and the negative ions must add up to zero. So all the negatives and positives have to cancel each other out. Ionic compounds are fairly easy to name if you know the formula. It's basically just a two-step process. Name an ionic compound. The cation, that positive ion, is named first. And then the anion, which is the negatively charged one. So we'll write that in here. This is the positive one, goes first. The negative one goes second. The other thing you have to know about the anion is that the ending changes to IDE. So with this example, we have the cation, the positive one, that's the calcium. So we name it calcium. And then the negative anion is chloride, or chlorine, sorry, but we change it to chloride. So instead of saying calcium chlorine, we say calcium chloride, HLORIDE. So change the ending to IDE. So when you have a compound and you want to write down the name, the cation, calcium, goes first, the anion, chlorine, goes next. Changing the ending to IDE. So we get calcium chloride. To go the other way, when you start with the name to the formula, a little more complicated, but it's not too bad. All right, so for this example, we have potassium sulfate. We want to change that to a name, to a formula. So we know the name, we want to write out the formula. So the first thing you do is you break this apart and write out its specific ions that you can identify here. So potassium we know is K. We also know it has a +1 charge. You look at the periodic table, it's in that first row or first group, first column, so it has a +1 charge. Now, sulfate, remember I said up here these all end in IDE. Sulfate is a little bit different. That means this is what is called, where do I want to write it? We'll put it right underneath. It's called a polyatomic ion. And in your tables that you got that are in the front of your chemistry binder, if you turn over to just the second page to table E, you get some common standard polyatomic ions. So anytime you have anything that ends not in an IDE but in an ATE most often or other things, you can find it here on this chart. So we see sulfate is right here. Polyatomic means it has more than one atom. It has sulfur and oxygen, right? And also a -2 charge. So looking on that chart, we see that sulfate is SO4 with a -2 charge. Okay. So we've got written down the ions that are that each of these names go with. Potassium is the K. It's got a +1 charge. We even know that because it's in group 1. Sulfate, SO4 with a -2 charge. We know that from the chart. Table E is very helpful. So the next thing we're going to do is write the formula. Remember, the charges have to add up to 0, which means for this one, I need 2 potassiums for every sulfate. Because that's a +1 charge, that's a -2 charge. So I need 2 of them, a K plus and a K plus, and an SO4 2 minus. 1 plus 2 minus 2 equals out to 0. So when we write the formula, we will write K2 as a subscript, SO4. Never write the charges in your final compound. But this shows me that I have 2 potassiums and 1 sulfate. +2 charge, -2 charge equals out to 0. Okay? Let's try a couple more examples, then I'll let you do some of them on your own. So here we have ammonium nitrate. You can look all over the periodic table, you will not find ammonia. It is another one of our polyatomic ions that we have to look on the chart for. So we see it right here. Ammonia, NH4 plus. So we're going to write down it is NH4 with a +1 charge. Then the nitrate ends in ATE, so we know it's also here on the chart, NO3 minus. NO3 minus. +1 charge, -1 charge. They even out without doing anything else. So I know the formula for this is NH4NO3, ammonium nitrate. Leave off the charges when you write the final formula. Okay. Let's see, let's try another one. I'm going to go down to 5 and then go back to 4. So nickel hydroxide. So nickel, we know from the periodic table. Nickel, Ni. Ni. If you look on your periodic table, I'm finding it. That's also in this reference chart. It's a very helpful thing. So if you look at this periodic table, find a nickel right there. It has a +2 or a +3 charge. Okay, so nickel is one of those ones, these transition metals, it can have either a +2 or a +3 charge. How do we know which one it has? Well, we'll hold off on that for a minute. Actually, when in doubt, go with the top one. I'm going to make that a rule right now. So nickel +2. Then hydroxide, if we look back at our table E, we find hydroxide right there, OH minus. OH minus.